Now here the sum of coefficients of all even powers of x in this product. The expressions two polynomials are multiplied together, that is 1 plus x square plus up to so on x to the power of 2n, and one more polynomial is 1 minus x plus x square minus x cube plus up to so on plus x to the power of 2n. Now you see these are the two polynomials multiplied together. Whenever you multiply these together, the least value you will get is the highest, the power of x least is 1 into 1. You will get start with the 1, right? And then x you will get, then x into x square, x cube, x power 4, like this you get. At the end, what is the highest power of x you are going to get? X to the power of 2n into x to the power of 2n. X to the power of 4n will be the highest power of x in this expression or in this product. So we'll have a constant, say a constant is a0, then we will have x term, we'll say a1x, then we have x square term, a2x square, up to so on. It will be end with a4n, x power 4n, which is a polynomial of degree 4n. Now here we have to find out sum of coefficients of all even powers of x. Now even powers of x means here x power 0 coefficient is 0, x power 2 coefficient is a2, similarly x power 4 coefficient is a power 4, up to so on the last x power 4n is also even coefficient, even power coefficient a4n. So what he is asking to find is, the question is we have to find out what is the value of a0 plus a2 plus a4 plus a6 plus up to so on a4. This is the value required to find out. Now to do this, what I will do now, there is a simple technique to find out sum of coefficients of all even powers of x. Just we take variable value 1, then we take variable value minus 1, then we will add. Right? So what is x equals to 1? If I substitute, what I will get? If I write just first a0 plus a1, x value 1 here, so a1 x square 1 square a2 up to so on. So you get a0 plus a1 plus a2 plus, if I want I can write some more terms to make you understand, a4 plus up to so on a4n, which is equals to, if I substitute x is equals to 1 here, all you get 1 1 1 1 1, right? So how many terms are there here? X power 1 if you count from here, x power 1 2 3, if you count like this, you have 2n terms, but if this is extra term you have, so totally how many terms we have? 2n plus 1 terms here and 2n plus 1 terms here. So here we get 1 plus 1 plus 1 plus 1, how many times? 2n plus 1, so therefore 2n plus 1. Now here if you substitute x is equals to 1, you can see that minus 1 plus 1 will be cancelled, left with only 1. So 2n plus 1 into 1 will become 2n plus 1. Now x is equals to minus 1 if I substitute, see right answer. X equals to minus 1 if I substitute here, a1 into minus 1, a0 minus a1, and minus 1 whole square, it will become plus 1, so plus a2. Then minus 1 whole cube, you will get minus 1, so minus a3. So right answer will become a0 minus a1 plus a2 minus a3 plus a4. So in that way you get alternative symbols. At the end you get plus a4n, which is equals to, now if I substitute x is equals to minus 1 here, minus 1 plus 1 cancel, and this is again plus 1, and x cube will become minus 1, so plus 1 minus 1 cancel. So keep on writing x value minus 1 till to the end. You get at the end one single term will be left with us, that is minus 1 whole power 2n. So minus 1 whole power 2n is plus 1, so 1 into this will be this only. So now if you substitute x equals to minus 1, the second bracket, x equals to minus 1, minus of minus 1 plus 1, and here you get again minus 1 whole square plus 1, and minus 1 whole cube minus 1, but minus, so plus 1, so you get 1 plus 1 plus 1 plus 1, so again you get 2n plus 1. Now if you add these two results, what you will get? You see minus a1 plus a1 and plus a3 minus a3 will be cancelled. a0 plus a0 2a0, a2 plus a2 2a2, so if I take common 2, a2 plus a4, like this you will get only the coefficients which are even powers of x. So a4n, which is equals to 2n plus 1, 2n plus 1, double of 2n plus 1, so 2 cancel. Can you see this? What we want actually we got a0 plus a2 plus a4 plus up to so on a4n, but this is given in the problem as 61. The problem, in the problem it is mentioned already that the sum is 61, so 2n plus 1 is equals to 61. So this implies 2n is equals to 60, which gives you the value of n, which is 30. Right. So this is a technique always we use. We substitute variable value 1 and variable value minus 1, and we'll add to get sum of the coefficients of even powers of x, and we do the subtraction. We do the subtraction whenever we want the sum of coefficients of all odd powers of x.